Toby, and I want to show off something I've been working on for the last couple of weeks. So first, some preface. I made a video a while ago about the Incredible Mandelbrot set, which is it's a discovery made by this mathematician, Benoit Mandelbrot, and he discovered this mathematical set of complex numbers that, when rendered in 2D, gives you this image. Now, what's incredible about this image is that you can zoom in to the edge of this shape, and you can see these little dots here along the edge of it. Those little details, when you zoom in, they emerge and you can see them more clearly, but within those details, there are more finer details within those details, and you can keep zooming in and zooming in, and there's always more finer details, no matter how far you zoom in. It's a very, very deep, and rich picture. It's an infinite image in a sense. And I have been, and if you haven't seen this video or you don't know what the Mandelbrot set is, either watch my video or go to Google and find another video talking about this. But this is such an incredible thing that it has got me really obsessed about this idea, and in particular the idea that there are many things in nature that have this property of having very many different levels of details. And I want to explore user interfaces that allow you to do that. And one of the great user interfaces, in my opinion, probably one of the most impressive software applications of all time, is Google Earth. And it allows you to navigate the Earth using this zooming and panning user interface. Now, I was visiting Abu Dhabi earlier today because I watched a video on CNN 10 about this desert, this Arabian desert, which is the world's second largest desert. And I was zooming in here, and the further you zoom in, the more detail you get. The farther you zoom in, the more detail you get. You can zoom all the way out to the point where you are looking at the planet itself, and it just looks like a marble. Or you could zoom all the way in so far that you can see the landmass, you can see the details in the land, you can see the forest. I'm not sure how far this particular image zooms. Depending on area, oh wow. Depending on area, there's different level of detail that Google Earth gives you. Like if you go to the Eiffel Tower, for example, you can actually probably stand, how do you spell Eiffel Tower? There. You can probably stand on top of the Eiffel Tower or something. So I really been geeking out on the Google Earth, and one game I played with my children was since we're not allowed to go outside anymore and travel, we can pretend travel by going to Google Earth and dropping. Where's Eiffel Tower? Oh, there it is. And like you can actually drop yourself into Eiffel Tower. Oh, there we are. And be right there in Eiffel Tower. So truly, I think Google Earth is really one of the most amazing applications that we we have the pleasure of experiencing. And yeah, so I wanted to do something like this. I want to understand how to build a user interface like this. So I did it. I did obviously not something as incredible as this, but a light version of something like Google Earth. So I built a deep zoom viewer for a file explorer that uses this concept of deep zoom. So this is a view of some directories, some particular folder in my computer, in particular this playground directory, which I use for various of my side projects. Yeah, when I make a side project, I make a folder in here. So this is a view into that directory, and what you can do is zoom in. When you zoom in close enough, then it will give you more details about the contents of the folder. So you can see Playground has these entries in it, some of which are folders and some of which are files. Deep Zoom is the project that I'm basically showing off right now. So if we went into there, you'll see that Deep Zoom has these files in it. I wrote it in TypeScript, so it's got an index.ts, server.tx. It's got a bunch of node modules. If you're curious about what node modules are being used to make this thing, there they are. If you're curious about a certain node module like fresh, what the heck is fresh? I wonder. I don't know. You can even drill in far enough to be able to read the contents of the files themselves. So what is fresh? Fresh is a HTTP response freshness testing. What does that mean? I have never heard about this. Check freshness of the response using request and response headers. If the response is still fresh in the cache, so it's about caching. I see, it's about HTTP caching. That's cool. So you can zoom all the way in and all the way out in this directory structure, and that's the idea. So you can see the contents of a directory, contents of a file, simply by zooming and panning, much like the manner with which you navigate Google Earth. Okay, so that's the demo, I guess. I guess I will explain a little bit about how I built this. The technology that's involved, it's quite dense. There's quite a few innovations that I've snuck up on here. On the other hand, the code is not that voluminous. So the front end code used to build this was 372 lines. The back end code was this Express server, with this 92-line Express server, which serves the contents of the file system, and I'll show you that in a bit. And this get first bytes is a JavaScript function I wrote for previewing a file, so that I can load the contents of a file, but only the first certain number of bytes, because I didn't want to load a large file in case the file was large. I didn't want it to load that into the browser. So I have the preview functionality load only the first 4,000 bytes of a file. Okay, that's maybe a bit much detail for now. But the way the backend works, the backend just uses the file system module. We're using the promises version of the file system module, which come out of the box for Node.js now, as I found out recently. And it has 3 APIs. One API, I'll just show you, instead of explaining code, I'm actually just gonna run the various endpoints. One API is called entry. Entry requires a path query parameter. Some say playground. So it'll tell you, given this path, it'll tell you what type of thing it is, whether it's a directory or a file. Those are the only two choices, and the name. And and then if it is a directory, then you can list dir, and it'll give you all of the entries within that directory. It'll also give you the type and the entry name for each of the entries. So you already know what the type of each child entry is. And then finally, there's if it's a file, such as this ds-store file, then you can get a preview. And you get the bytes of the file. This is a binary file, so you're not really making that much sense out of it. So those are the only backend APIs that I supply. I'm not gonna dig into the backend code that much. If you're familiar with Express, you should be able to read it. And I have published this code on my GitHub under airportyh/deepzoom if you're interested. But most of the interesting bits, I would say, are in the front end. So the front end is done using the Canvas API, and there's a couple pieces of technologies that there's one piece of technology that I came up with several months or maybe even over a year ago, where I came up with this fit text function, which is able to fit text within a bounding box. So, and I'm not gonna get into the code too deeply, but I'll explain how it works, okay? So given a bounding box that you have, oops, let me try that again. So if you have a bounding box and you're saying, I wanna fit some text into this bounding box. Let's say the text was hello world. Please fit this text in it. Well, fit text will do its best. It does a really good job, I would say, of fitting this text within the bounding box while maximizing the font size of the text. So it'll put it right in the middle, and it'll make the text as large as will fit into the box. And it also works for multi-line text. This is an adapted and more simplified version of the fit text function that I've written in the past. The previous one that I made did word wrapping, but I simplified this one, and this one does not do word wrapping. I did that for performance tuning reasons for the deep zoom viewer. Okay, so and just a word about how fit text works. The way fit text works is it uses this modification of a binary search method. So first it just tries a number of font sizes until it finds the font size that is best. And how does it do that? It starts with a very small font size, 5. So 5 means 5 pixels. 5 pixels. So if you render Hello World at 5 pixels, it probably look like this. Even smaller than this. It'll look like this. And then it'll render this, or not actually render, it'll ask the Canvas API to measure the width of the text, which that is a Canvas API. Canvas API does that. I have a text measurer that does that. I implemented a text measurer that wraps around the Canvas measure text method because I needed caching to speed up the rendering process. So my text measurer caches the calculations of the Canvas's version of measure text. Okay, so it'll basically say, okay, try this font size. Does it fit in the box? Well, clearly it fits in the box because it's tiny, right? So if it fits in the box, it's gonna double the font size. So if you double the font size of, and well, I'll just write over this guy. I'll use the, okay, so if you double this font size, it'll be like hello world and you ask, hey, does that fit in the box? Yeah, then double it again. Does that fit in the box? Yes, double it again. That still fits in the box. Now we're gonna double it again. Now finally it doesn't fit in the box. When it doesn't fit in the box, we're actually gonna take the new font size, which is that, whatever that font size is, and that font size, and we're gonna do a binary search on it, right? Like we have a lower bound and an upper bound. Let's say the lower bound is here and upper bound. We're gonna find the midpoint and check that, see if it fits in the box. If it fits in the box, then we'll subdivide further and find the midpoint in here. But if it doesn't fit in the box, we'll find the midpoint here and so forth and so forth. So that's basically a binary search. So it's a modified version of binary search. Well, starting the lower bound at 5. I don't know if it's modified. Maybe it's just the binary search. Okay, so that's how fit text works. Fit text is, I use fit text so that regardless how large this bounding box is, this text will be nice and centered and large. The size of the text will be scaled to the size of the box. Okay, so that's what fit text does. That's one major clever part of this application. The second major clever part of this application, there's probably 3 or maybe 4. But the second major clever part of this application is the fact that this rendering algorithm, the algorithm that's rendering what you see, it is smart enough to only render the pieces and only fetch the pieces that is visible on the screen at any moment. And also that works in terms of level of detail. So for example, right now we're looking at just the playground directory, nothing else. So it doesn't need to fetch its children to render them to you, because we're not looking at that level of detail yet. But if I zoomed in more, now we're showing more level of detail. So now it needs to fetch its children and render them as well. And then, but if you zoom in more, now you notice that only some of the children or some of the subdirectories are visible on the screen, which means there's no need to render the directories that are actually not on screen here. So basically the processing that the program has to do in terms of rendering, the rendering processing that it has to do, depends on the viewport and the zoom level, which zoom level is part of the viewport. And that is the trick. That is the trick. And we have this variable called viewport. And whenever we change the viewport, we make a new viewport and set it. This math to figure out how to zoom using the mouse wheel was actually quite difficult. Oh, and also one thing about this zooming. So I'm using the mouse wheel to zoom. Like if I had a table mouse or a click mouse, then you can use the mouse wheel to zoom. This is how Google Earth works as well. But if I'm using a trackpad like on a Mac, which I am, then it's a 2-finger scroll. Or if you can configure your Mac to allow you to touch the trackpad with 2 fingers simultaneously and then move up and down. Or you can also use the pinch motion to pinch, and it does actually the same thing. And by default, this is a native behavior, but they exposed it in Chrome as a synthetic mouse wheel event. And the only way you can make use of it is if you did a prevent default. If you didn't, on the window, you have to add event listener on the window object and then prevent default. If you didn't do that, then this zooming would not work. Or is that true? Oh, it kind of just interferes. The native zooming kind of interferes with my zooming, so I don't want to do that. Okay, so if you want to make this kind of zooming interface, this is the stuff. You need to listen for the window objects wheel event and prevent default. And then once you have this object, the wheel event object, it's got a delta y, which is basically what you need. And then that's my delta, and I'm gonna use that to increase or decrease my zoom level. And then based on that, I have to figure out my new top left corner, because if I zoom in, then my new top left corner here, that's gonna change. And that math was actually quite hard to figure out because I'm not a computer graphics or video game expert, even though I had some of that in college. It just took me a while to figure that stuff out. Okay, so there is that. I'm kind of rambling through, so let me see. I'm gonna summarize what we talked about so far. So there's the fit text function. That's one cool thing about this, and then there's the wheel event, and then there is the render only as needed aspect, which I think is really cool. I'll show you a little bit more about that code. Yeah, let me show you more what I mean. I did show you let me just show a little bit of that code. So here there's a calculation that this render entry is going to render each box, basically, which represents either a file or a directory. So basically when I say entry, that means file or directory. Okay, so render entry, so this box and this text within the box, that was drawn by render entry. And how does it decide whether to draw the box or not? Well, it based on how much of its area is visible on screen, and it calculates that here. This is the amount of width of this box that is currently visible right now, and this is the amount of height of this box that's currently visible. And if both of them are negative, I'm not rendering this thing, so because it's not needed. So we got box north of here that are not visible. They're gonna hit this early return path. We don't need to render those boxes, and that's beautiful, because performance can be an issue with this kind of user interface, to make it zoom smoothly. And right now it's not even that smooth because QuickTime is recording this screencast and my computer is screaming like crazy. Okay, so that's one clever trick. Another clever trick is this on-demand fetching of directory listings. Okay, and I had a few different iterations of methods of getting that, until coming to this place where I'm pretty happy with it. So basically, as I was saying before, if depending on the level of detail you're looking at, you need different levels of information. So if you're just looking at this, we actually don't need to know what's inside the playground directory. But if you zoom in a little bit more, then we need to know it. So this is saying if the scale is greater than 0.5. What does scale mean? The scale means the ratio between the area of this box to the area of the viewport. If that is greater than half, which at this point it's not, but if you zoom, at this point it is. So this area is greater than half of the area of the viewport. Then we're gonna start trying to render the stuff inside the directory. And then I have this method called fetch directory listing. This triggers the network call to send a request to the API to fetch the children of playground, whereas this guy will actually get it if it's ready, but it may not be ready. So this fetch is happening asynchronously, while this render function is not asynchronous, is synchronous. So if you fetch this for the first time, this will not be ready yet. And if it's not, it'll hit this early return. So it'll actually have to wait for the next turn of render, next time render is hit, before the directory listing will actually be ready. And then we go in and loop through the entries and actually render them. So now what kicks off the next render? Well, whenever you fetch something, when the request comes back, it sort of sticks the results into a cache, and then it requests another render. So that's how that works. So then the next time when the directory entries, the directory listings are back, and then it kicks off another render, now it hits this point and it'll actually get some entries. It'll still call fetch directory listing, which will actually not do anything if you've already sent that request out. And then this goes through each entry that are in the directory listing and recursively calls this render entry again, and then does the same thing. And then I have the same technique for file previews. The file preview fetches the first 4,000 bytes of the file. If we're looking at basically if the box representing that file is 0.6 of the total 60% of the area of the viewport, then it'll start fetching the preview for the file. And if you zoom in more, then it doesn't show you the title anymore. Then you can sort of read the text. Okay. Yes. So that was this third point, which was it only renders as needed. And then the fourth point I want to mention about sort of interesting stuff, that techniques that are being used here, is the way that this on-demand fetching mechanism works. So I have caches for each of the API calls. So my backend calls, there were 3. I'll review those. There's an entry to just get it's for each path. What's the name of the file, which you more or less already know, so that's not important. But the more importantly, whether that's a file or directory, is given by this entry. This one is actually only used for the root, because for the children it's not needed, because list directory actually gives you that information for each child of a directory. And then there's the preview API call. So those 3. I have a cache for the file entries, I have a cache for the directory listings, and I have a cache for the preview. And as is needed, the render method, because it's the render method that knows what data is needed, because all of that is based on the viewport. Like, depending on what the viewport is, what the user is looking at, the render method knows what data is needed to render more detail for the viewport, right? So because of that, you have this situation where the renderer is responsible for fetching data. For example, here we need to fetch more directory listing because we're at a level of detail that needs that. Here we need to fetch the preview for the file because we're at the level of detail where we need that. And when that happens, it kicks off this API call. When the API call comes back, it'll stick it into this cache. But while it's making that API call, it's put into this pending state, so that additional calls requesting for the same thing won't send out more requests for a duplicate thing. And when things come back, it'll stick it into the cache and request another render, and then that render, if it still needs this information, it'll pick it out from the cache and utilize the data. So I actually tried a couple of different ways of doing this. I tried making this render entry a async await function like this, and then do this asynchronous fetching within the renderer loop. And that was not a good story, because what ended up happening when I did that was hello. So what ended up happening when I did that was, when I had a large number of boxes on the screen, such as now, then the render process was actually asynchronous, as in, I think there was a little bit of breathing after rendering each entry. So I would see these boxes progressively being drawn from left to right, and then second row and third row and so forth. And I came up with a job mechanism to sort of progressively, so that while if the previous render is still happening, and then I want to restart the render, I would cancel the previous job and then start a new one. That sort of worked, but it was not good enough. I still got this progressive painting of the boxes from left to right and top to bottom thing, and that was not a good user experience. So the fix was make the render method a synchronous method, or function in this case. I'm actually not using classes in this code here. So make it synchronous, and instead I chose to do this fetching and then re-render mechanism, which is currently working quite well for this application. So yeah, I guess that's what I wanted to show you. This is the kind of thing I'm looking into right now. I have ideas of other domains that could use this technology. So file directories is only a simple and familiar use case, but there are many use cases, I think. Like project management is one, software projects is one. There are many projects or hardware systems, computer circuits. There's a lot of systems that are very, very complicated with many different levels of detail, where you can make use of a deeply zooming user interface. And least we forget about the time traveling debugger, which I have been obsessed for a long time and still are. One reason I really dug into this deep zooming interface is because of that, because I thought of a way of looking at the history of your program, as in all the steps that your program took over time, looking at that via a deep zoom user interface. So that's another thing I'm going to be pondering, and hopefully bringing, at least making some of a proof of concept in the future. But yeah, that's all I have to show you. And I hope to be making another video soon. Until then, I will see you later.